Assalamualaikum and hi everyone. So in this video we are still in chapter 6.2 equilibrium constant, but we are going to learn learning outcome E. That means you should be able to determine the degree of dissociation alpha by the end of this video. Degree of dissociation alpha, okay, so symbol untuk degree of dissociation adalah alpha. So first you should understand what is dissociation. Okay, so dissociation reaction is a chemical reaction whereby a molecule is broken down into smaller molecules, atoms or ion. So dissociation ni adalah penceraian lah. So kita ada satu molekul yang besar, molekul tu kita break down into smaller molecule, atom atau ion. Okay, so the fraction or the percentage of molecule that dissociate is called degree of dissociation. So kita ada satu molekul, tapi dalam molekul tu berapa banyak yang dissociate, itu yang kita nak cari. Okay, and that is called degree of dissociation alpha. Okay, so if dissociation occur completely, so percentage of dissociation dia akan jadi 100% lah. Okay, tapi kalau pakai degree, dia akan jadi alpha equal to 1. Okay, so if dissociation is incomplete, then the value of alpha can be calculated as follows. Okay, so not all the time dia 100% dissociate. So kita boleh kira lah kalau yang bukan 100% tu by using this formula here. Okay, so alpha equal to concentration change, okay, divide with concentration initial. Okay, and then kalau kamu nak dia dalam percentage, that means you have to times 100% lah. Alright, so next is example of dissociation. Okay, so example of dissociation adalah thermal dissociation. That means this dissociation require heat lah. Okay, so thermal dissociation is a reversible reaction brought about the application of heat. When cooled, the product bond again to give the original compound. For example, this PCl5 solid, okay, and then dia akan dissociate bila kita apply heat, jadi PCl3 and Cl2. Okay, so the same goes for N2O4 dengan NH4Cl. Itu je lah untuk yang nak disampaikan dekat sini. Example of dissociation adalah dengan cara kita apply heat. So nama dia thermal dissociation. Okay, so kita tengok example sebab kita nak belajar macam mana nak kira percentage of dissociation. Okay, so in this question, dia bagi kita 0.024 mole of N2O4 is allowed to reach equilibrium with NO2 in 0.372 liter flask. Okay, and the temperature is 25 degrees Celsius. Lepas tu dia kata calculate the percentage of dissociation alpha of N2O4. That means dia nak tahu berapa banyak N2O4 yang dissociate to form product. Okay, and dia bagi kita nilai Kc juga. Okay, this might be useful later on lah. Okay, so this question is not that straightforward lah. Sebab kalau kamu perasan formula nak cari degree of dissociation ataupun percentage of dissociation adalah ini. Okay, so maksudnya kamu kena ada concentration change. Okay, so that means you need to know how many of N2O4 ni yang bertukar jadi NO2. Okay, so kena tahu in terms of dia punya concentration dia lah. Tapi kita tak tahu. So, that means kita kena cari ni dulu. Concentration change for N2O4. Lepas tu, concentration initial tak ada masalah sebab dia dah bagi 0.024 mole ni. Okay. Cuma kita kena tukar kepada concentration je lah. Okay, dan kita akan dapat concentration initial. Okay. So, macam mana saya tahu this is mole initial? Okay, sebab ini dia kata N2O4 is allowed to reach equilibrium. That means this data given adalah data initial lah. So, ini maksudnya kita kena buat table lah. Alright, so let us look at the calculation here. Okay, so saya dah isi dah dia punya equation atas ni. Okay, and then I need to find the initial concentration from the number of mole initial given for N2O4. So, senang je. Saya mole divide with volume lah. N over V dapat concentration. So, this is the concentration of N2O4. And then for concentration of NO2, saya letak 0 sebab as you can see, there is no information about NO2. So, kita assume kalau tak ada information about product, that means kita assume initially the product is 0 lah. Okay, and then the change depends on the stoichiometry. Since ini 1 je, so minus X. Okay, and then this is 2, so plus 2X. Okay, so the equilibrium concentration should be 0.06452 minus X, and this is 2X. Okay, tapi our main point adalah kita nak cari percentage of dissociation. That means kita kena tahu berapa banyak change yang dekat sini lah. So, we need to know the value of X. Okay, so kita kena cari nilai X from the value of Kc given. Okay, so this is the formula for Kc. Okay, concentration NO2 power 2 divide concentration N2O4 power 1. Then we need to plug in all the values. Okay, and then kita cubalah untuk solvekan nilai X. And it turns out ada dua nilai X yang saya dapat. Okay, satu positif, satu negatif. So, in this case, kita tak akan ambil yang this negative value lah. Sebabnya, if you substitute this negative value masuk dalam this equation, the concentration at equilibrium for NO2 akan jadi negatif. So, which is wrong lah. Okay, so that's why kalau soalan yang macam ni, kamu tak perlulah nak show your substitution. Just boleh fikir sendirilah. So, this value is not acceptable. So, that's mean this one yang kita akan guna dalam pengiraan kita seterusnya. Okay, so seterusnya kita nak terus cari percentage of dissociation lah. Okay, so this is the formula for percentage of dissociation. So concentration change over here adalah nilai minus X ni lah. Okay, tapi tak perlulah nak ambil minus ni sekali sebab kita nak tunjuk perubahan, berapa banyak perubahan. So just take the value of X. Okay, so ambil value X sahaja yang daripada sini. Lepas tu kita bahagilah dengan concentration initial. Okay, and then you should get percentage of dissociation for N2O4 adalah 12.50%. That's mean out of 100%, only 12.50% of N2O4 yang bertukar jadi NO2. Okay, right. So, next thing adalah, kalau kamu perasan kat sini, concentration change is not always X. Okay, so please remember that because kadang-kadang it might be 2X over here. So, kalau 2X over here, so maksudnya change kamu adalah 2X lah. Okay, so dia bergantung kepada change yang dekat sini. Okay. Alright, so senang sahaja untuk degree of dissociation. Step yang lain sama je, cuma dia ada extra step untuk kira percentage ataupun degree of dissociation tu sendirilah. Okay, so I think that is all for degree of dissociation. So thank you semua. Bye bye.